first we will solve this inequality. To solve an inequality means find all the x values that satisfy this inequality. Okay, so first step is you make the left side equal to 0. You will have x squared plus x times x plus 2 times x minus 3 squared. Make it equal to 0, and we want to find the zeros of this equation. Well, it's pretty obvious we have 3 solutions here. One is 0, one is -2, and one is 3. Okay, so now that we find the zeros of this equation, you want to put these 3 zeros on a number line. So starting from the smallest one, -2. -2, and the next one is 0, and the greatest one is 3. Okay, so now we want to decide or check if each 0, -2, or 3, are satisfying the original inequality. Okay, so in our case, if you plug in -2 into the original equation, the left side is equal to 0, right? So this means it is satisfying the inequality because 0 is greater than 0. So -2 is a solution to this inequality. Now check the 0 here. You plug in 0 into the original inequality, and the left side is equal to 0. So 0 is greater than 0. 0 is also a solution to this inequality. So is 3. 3 is also a solution to this inequality if you check, plug it back into the original inequality. Okay, so first we decide these 3 zeros are solutions or not. Then we will decide if each interval divided by these 3 values are solutions to the inequality. So we can tell the number line is divided into 4 intervals. First one is -infinity to -2, and the next one is -2 to 0, -1. The next one is 0 to 3, and the next one is from 3 to infinity. Okay, so how do I decide if values from each interval will make the original inequality true or not? We will put a test point. So we will pick a test point from each interval. And if that test point is making the original inequality true, then the whole interval will make the inequality true. Okay, so pick a test point. Well, I will just pick any point from first this interval. I would say -3 is in that interval. From the second interval, I will have -1. Next interval, I will have 1. And the last interval, I will pick 4. So 4 is between 3 and infinity. Okay. So I picked my test point, and now I will plug in the test point into this expression. In our case, is the left side of the inequality. Okay, so I want to test if each test point is making this expression positive or negative. Okay, so first we plug in -3 here. Well, you have to agree that x squared and x minus 3 squared, they will always be positive for our test point. So x squared, positive, right? Plug in -3 into x plus 2, you have -3 plus 2, which is negative, times -3 minus 3 squared, positive. Okay, so overall, it's negative. I don't need the value. I just want to know if it's positive or negative. Okay, now plug in negative 1. Negative 1, you will have positive, which is negative 1 squared, times negative 1 plus 2, positive, times negative 1 minus 3 squared, positive. So overall, positive times positive times positive, positive. Next value, plug in the 1. 1 squared positive, 1 plus 2, positive, 1 minus 3 squared, positive, overall positive. And the next interval, plug in the 4. 4 squared is positive, times 4 plus 2, positive, 4 minus 3 squared, positive, overall is positive. Okay, so what does it mean now? It means that this interval from negative infinity to negative 2, any point from this interval is making this expression negative, and all the other 3 are making that expression positive. So what do we need? We want this expression to be positive. That's the solution we want. So our solutions should include these 3 intervals and those 3 points we decided. Okay, and so look on the number line, our solution should be from negative 2 all the way to infinity, and with negative 2 included, right? Because negative 2 is included, 0 is included, 3 is included, and all these interval is included. Your solution or solution set is from negative 2 all the way to infinity. To infinity. Because you're including this interval, this interval, this interval, and these 3 points. Okay, so now we will solve a rational inequality here. Okay. So let me write rational inequalities. Say solve this rational inequality. X minus 5 squared over x plus 2, x minus 1. For example, I want to see if that is greater than or equal to 0. So I want to find all the x values that satisfy this inequality. Well, this is a rational inequality. So same thing, we want to find all the zeros, but in this case you want to find all the zeros from the numerator and all the zeros from the denominator. Okay, so the zeros from the numerator will be 5. And the 0 from the denominator here will be negative 2 and 1. Okay, so those 3 are the 3 points we want to put on our number line. So put it in the right order. First is negative 2, then it's 1, and then it's 5. Okay, so next we want to decide if 5, negative 2, 1 is making the original inequality true or not. So first let's test on this negative 2. If you plug in negative 2 here, the denominator is equal to 0. So that means that is not defined, right? The left side is not defined. So this cannot be a solution. Test on 1. Similarly, if you plug in 1 here, this left side won't be defined because 1 will make the denominator equal to 0, and you know the denominator cannot be equal to 0. So 1 is not a solution. Let's test on 5. If we plug in 5 here, 5 minus 5 squared will make the top equal to 0, and the bottom is not 0. So 5 is a solution because 5 is making the left side equal to 0, and 0 is greater than or equal to 0. So 5 is a solution. Okay, so we decide these 3 points, some are solutions and some are not. So now let's look at the intervals separated by these 3 points. We have 3 intervals. From negative infinity to negative 2, that's one interval. From negative 2 to 1, that's another interval. And from 1 to 5, that's another interval. From 5 to infinity, last interval. What do we want to decide here? We want to know if the points in each interval will make x minus 5 squared over x plus 2 times x minus 1. This expression positive or negative, right? Okay, so now we want to pick a test point. So pick a test point from each interval. Okay, so test point from the first interval, I'll pick negative 3. Test point from the second interval, I'll pick 0. Test point from third interval, I will pick 2. Test point from the fourth interval, I will pick, 6. Okay, so now I want to test if each interval will make this expression, or each test point will make this expression positive or negative. I don't care about what values I will get, but just check on the signs of the result. Okay, so first plug in negative 3 into that expression. So on top I have, well, the top will always be positive here. So negative 3 minus 5 squared, it's positive. Over at the bottom, negative 3 plus 2, that's negative. Times negative 3 minus 1, negative. So overall, positive divided by negative times negative. On top is positive, on the bottom is positive, overall positive. Okay, now try 0. Plug in 0 into this expression. 0 minus 5 squared, positive. Anything squared is either 0 or positive. Okay, 0 plus 2, positive. 0 minus 1, negative. Overall, negative. Next one, check on 2. 2 minus 5 squared, positive. Over 2 plus 2, positive. 2 minus 1, positive. So overall, positive. Next one, check on 6. 6 minus 5, positive. Over 6 plus 2, positive. Times 6 minus 1, also positive. Overall, positive. Okay. So which interval is making this expression positive? Well, it is this interval, and that interval, right? So our solutions should include these 3 intervals I just circled and 5. Okay, so my solution set should be, first include the this interval, negative infinity to negative 2. Okay, union, I can't include negative 2. Remember, that's not part of the solution. Union, okay, so union this interval plus this 5 and plus 5 to infinity. So to conclude that, that will be from 1 to infinity. Okay, so this is our solution set.